Well, this is a management console, as known as GUI. This is connecting to the controller, and the controller is separated machine. As Don said, the controller is running on the next machine. And right side is a console of the controller. So this is a very usual bash shell. And now management console is here, and there are 4 switches. 1, 2, 3, 4. The connection is like a factory. So now there are 2 equal passes from, for example, from 1 to 2. There are 2 passes. One is beer PFS 3, and second is beer PFS 4. PFS is programmable for switches. The product name of NEC is OpenFlow switches. Okay, now, and as Samrat explained, the basic idea of our product, which means programmable flow, the basic idea is VTN, Virtual Tenant Network. This is an isolation domain in the physical network. So VTN is a logical network. We can define the VTN, and if the servers are belonging to the VTN, the servers can communicate with each other. Unless that, the servers cannot. So that means, and okay, so let's say, which one? So many virtual machines, but let me use this virtual machine. This virtual machine's IP address is, it's a little bit small, oh sorry. This virtual machine IP address is 192.168.100.121. The subnet is 100. So ping to 192.168, 100, for example, 1, 2, 3. It doesn't work now because there is no VTN between the pinger and the pingy. So let me define the VTN between them. It's add VTN. The name is, for example, L21. And defining that, setting up. I'm putting a vBridge, virtual bridge on the VTN. So bridge name is simple VBR. It's arbitrary, and and oh, this machine is belonging to the VLAN 121. So input VLAN number 121 and some needed something, and okay. Now vBridge is here, but it doesn't work because the configuration of the PLC programmable flow controller, which is the product name of our OpenFlow controller, the configuration of PLC is, the strategy is a transaction. If we configure something, but until the commit, it's not effective. So we have to commit that. Push commit button and apply. Okay, but it doesn't work. Why? There is a reason. This machine is 121. I mean, VML21 is here, and oh, sorry, and 13. Oh, port group is not, I expect. So, okay, change the port group, and then it starts working. Now it's perfect. So that means, that suggests that if the port group is created as I expected, and if the virtual machine is now belonging to the port group, and the VTN is properly created, the virtual machine location doesn't matter. So even if virtual machine is host 1, host 2, host 3, it doesn't matter. All you need is to configure the virtual machine to make it belong to some port group. That's all. So
do you automatically get the port groups from vCenter?
now there is no way, obviously. Right.
But there would be the possibilities there.
Yes,
In
right.
October,
Yes.
perhaps.
And the port groups in VMware have to be VLAN based, right?
Yes, because now the
Actually,
VTN,
you're working on VLANs.
right, now the VTN is mapped on the VLAN. So this is a reason.
Yeah, sure.
Yeah.
Then there has to be an interface between ESX host and your first switch, and that's still VLANs, right?
Right.
Okay.
And on the management console, we can see the physical route. Well, this is probably first from 2-1 to 2-3, and there are two flows, which means bidirectional, back and forth.
Question.
Yep.
Does the flow from A to B has to be the same path from as B to A?
Sometimes they are different, but
Okay.
usually they're same.
But could I force it to take the different route for whatever reason? Not that I would want to. It's just. Would it be possible to do?
Yes, if I configure something, yes, it's possible.
Okay.
Can I force them to be the same
That's another
for
valid-
symmetrical
Yeah.
traffic reasons?
The reason of using the same path.
No. Can I force the return path to always be the same as
Oh.
the forward path?
Fourth, yes, it's possible. It's possible.
Okay, very good. That's even better question than mine. Mine was actually a different one.
Of course.
Okay, now there is only one VTN. So, and next example is different machine. This machine is L2-2 is here, and now let me pin to 192.168. Same subnet, but different machine. It doesn't work because this machine is not belonging to the VTN. So let me define the second VTN and simultaneously. Oh yeah, second VTN. And I forgot to mention. Well, now there is one VTN which is configured on the PLC, and I configured that on the management console. But the actual configuration is, of course, sitting on the controller itself. So the CLI of the controller is PLC shell. So let me launch that. Oh, it's slow. And the actual configuration is here. Suddenly it's slow. Why? The running configuration. This is the first VTS configuration. It's very short. And of course, we can, for example, we can save it to text file. Can do text or something. And of course we can
So it has curly braces, but it uses show run.
edit that. And this can be run as a script from the controller CLI. So what I mean is GUI can be used to create a template, and later we can modify that for more complex script.
The programmable flow controller, is it a separate application that, let's say that I want to purchase the product? Would I have to buy the GUI, or could I just go with the CLI?
They are all built in one DVD.
Yeah,
You cannot buy it without the GUI, but
Okay.
you're not forced to use it.
Fair enough.
Oh yeah.
But you're not a good answer. So you're not forcing it as as the approach as a separate product.
Yes.
Yeah, very good. Many vendors make that mistake, and I had my fair share experience of.
So what I think is interesting about this output right here is that that interface name corresponds to some port on some node, right? You have underneath there?
Mm-hmm.
So this is what I was talking about, network single system image. Really, it's managed as one continuous entity, the collection of all the nodes.
So is that a MAC address there? Is that based on a MAC address, or is that?
No, here's no MAC address.
Where you say interface VV1 F00001?
Well, yes. In this case, this doesn't make sense. Interface is not needed absolutely, but
no, I think it's asked a question that we're VLAN map in this case.
Oh yeah. Oh yes. In this case, VLAN map. So this.
So, I mean VLAN ID, but this is interface V. It's kind of small, but
right.
V1.
Yeah.
Where's it
something.
get that name?
Yeah, where's that number? Where's that V1 F0 come from? Is
That is arbitrary name. That is
Okay.
named from GUI, but it's arbitrary.
Basically, in this case, it doesn't matter because
It's
he's
GUI
doing a
generated,
VLAN
so
map.
it can't make sense.
okay?
But I maybe ask the question asked differently. If another VM with the same VLAN ID comes on, what happens? So
No, I was just curious as to where
By
those
the way,
naming
this
conventions come
interface
from.
that you have here,
Mhm.
is this like the switched virtual interface that represents this VLAN?
It's a,
So can you
it's a
run-
virtual representation.
Yeah,
Yes.
so can you route between this interface and some other interface?
In logical world, yes.
Yeah.
The interface is actually now the interface is not used, but
Okay.
after the functionality of the interface is the connection point between the logical entities. So I'll show you that.
So it's like SBIs in the switches.
Yeah, that's
Oh,
not
okay.
a physical port. with
Yeah.
the
So that's not a
same,
physical port then?
No.
That's the VTN or the VBI.
So that said, what's a physical port look like? What's one of the switch ports look like in the
In the
console?
config.
Yeah.
Because we're asking the same question over and over. We now know it's a virtual port. What's a real one look like?
Yeah, it can just a regular VTN script.
Oh yeah, sure.
wanna add a
next
physical
one,
port to
next
that
one
view.
is like that.
Okay.
Alright.
In short,
Will come there.
we have two methods to map the logical thing on physical thing. One is VLAN map here. This is the logical VTN is mapped on the VLAN, so it doesn't matter with the location, physical location. But second method is to map the physical port. In that case, we have to write the port number in the switch, which switch. So, so let me show that.
We're going to show that. Yeah.
Okay, so now the simplest case is over, and the second case is also let me define. Sorry, the VTN again. So run the script, and I prepare the script. Well, which one? I have to which one? Yes, and running that, and you see that now this starts working because now we have the VTN for this machine. And for your question, show running config again. This VTN is using the interface map. In that case, we have to map the V external, which is a logical node corresponding to some side. This should be on the edge side of OpenFlow world. Is mapped on this switch. This is the switch ID and this port. That means VFS1 in this case, the port 3, and VLAN.
Switch ID is dynamically generated or is it static?
Well, in this case, static.
Okay.
Because our switch, we can configure the. This is called DPID, data path ID. We can configure DPID on our switch, but sometimes some switch does not provide a way to change that. So anyway,
Can I make this into a name so that it makes sense to me when I look at the config?
it makes sense, but it's impossible. Now it's just number.
Okay.
And in which format is it? It's too long for a MAC address, right?
Where's that
number?
Oh yeah, DPID,
Oh, just
yes.
a 64-bit number.
64-bit number. Yes.
So something I've been thinking about as I've been watching this go through is remembering back to the last presentation is it's a little tough wrapping my brain around the endpoints, the end nodes, either the ESXi host or the bare metal installation, behave in a regular way, behave like the switch is doing regular MAC learning and default gateways. But there's a kind of a weird disconnect between the interface because OpenFlow doesn't treat it like, you know, OpenFlow doesn't, when you're switching stuff through an OpenFlow fabric, it doesn't seem to pay much difference between a MAC address and an IP address. They're just all tuples and.
Well, exactly what it does is defining the controller. And here we have that vBridge construct is something that's, that construct imitates MAC learning, right?
Yeah, and when you do an ARP, the local node, the local OpenFlow switch will do the ARP reply with a fake.
No.
No, not necessarily.
No, it will go
So
to
you don't do ARP spoofing yet.
no.
Okay.
Okay.
But from there we create the stations. So effectively, you're right. It's not MAC or anything. It's the concept of the stations we try to find out, and that's by looking at the ARP. So the controller is looking at the ARP, the response, so that it can create the stations.
So I'm that host on the left, and I'm about to send out a ping. So I send out a ping. I do ARP. Who has my default gateway? Who responds?
The ARP request to the ARP request.
Yeah, who responds to that Linux machine on the left? So I get a IM 192.168.1.1 default gateway. Here's my MAC address. Who responds? Who's the one that issues that response?
The other machine?
The other
Yeah, the other machine.
They flag the ARP.
Well, I mean, but there are. Let's say they're on different VLANs, and I'm doing
Well, then whoever is the next hop gateway.
right. But who is the next hop gateway?
Oh well,
That's
Oh, okay.
Next hop gateway could be an external router. You should think of this as
No,
this
no,
one.
no.
No, yeah, so
he
can
has
have-
two layer 2 subnets,
Yes.
and he's routing between them.
Yes.
Who is the next hop gateway?
Yes.
Right.
He
So
is.
if I remember correctly, last time it was the local. You define a virtual router,
Yes.
and the virtual router is what responds, but it's the local OpenFlow switch that is the one that responds. So
it's just like having an SVI on the switch.
not quite, because an SVI is on one single switch. In the
Unless you're
OpenFlow-
Arista.
unless you're Arista.
Okay.
Or unless you're
So the question is that
Juniper
if you
OpenFlow,
try
or
to
Juniper
ping the
QFAP, yeah.
gateway,
So
also we can get.
So on
Yes,
a
it
regular
is a-
SVI, like
does
if
it-
I
do you
have
get a
a,
response?
you know, 4
Controller
Nexus
does that,
5000 switches, I have an SVI on one
So-
of them, and I ARP on the far end. That ARP reply comes from the switch with the SVI. In OpenFlow, if I remember correctly, you define a virtual router, like a
Yes.
virtual SVI. And I do an ARP. I'm plugged into my local OpenFlow switch. I do an ARP who has 192.168.1.1. It responds with a MAC address that's defined, but the ARP reply comes from that local OpenFlow switch, not the far end.
So again, that may be the way they implemented it, but what you're talking about is not. That's not intrinsic to OpenFlow.
Right. And there's other people that do something different, but a traditional SVI, that's not the way it does it. The traditional SVI, it comes from one device usually.
So I think your question is also that if you have the virtual router which you've seen, and if I want to find out that virtual router, that gateway, then who responds to that?
Yeah, who responds? So I know who virtually my virtual gateway is. So it's a virtual
And it
router
can be,
installation.
you don't know where it is. Because
I don't
it's
know
an
where
image.
it is, but man, in the
So-
ARP reply is a single MAC address, but it comes from whoever the local OpenFlow switch
So
is.
in this case, it is the controller which is basically acting as that virtual router.
Okay, so the ARP reply actually comes from the
Yeah.
controller, not from the OpenFlow switch. Okay.
If we have two hosts talking, it's routed traffic between two VLANs, and the two hosts are attached to the same switch, is the traffic always local to that switch? Even if we can route within that switch, we can route within a different switch.
Yeah.
Everywhere, so it's all
There's-
distributed.
Yeah, it wouldn't hairpin like in a normal SVI, like a
Right.
traditional SVI.
Basically, the way if it works is that it's essentially the edge, the most of the intelligence on stream. It goes to the controller finds out the path, and then it distributes the path between the edge, and then it does that.
And it would just be in the local TCAM. So, kind of interesting question is,
It's
well,
not
how,
just TCAM though, it's header rewrite.
Well, this is the thing. It does work like a traditional SVI. What's different is the physicality of this. Think of those switches as line cards.
I think that's the correct way to
Think-
think of it,
think
but I
of the-
heard something that worries me quite a bit. You said that it will be the OpenFlow controller that will respond to ARP requests. So what if I flood 10 gigs per second of ARP requests to the OpenFlow controller?
You're dead.
For the virtual
control plane
router,
policing?
Sorry?
for the virtual
Control
router
plane
gateway.
policing.
Yeah.
Yeah,
For normal, it goes to the normal.
for the virtual
Yeah,
gateway.
for the virtual gateway. I mean, do you have a kind of a protection feature for that would be kind of protecting the controller itself from the attack by the end users? Because I was under the impression that the OpenFlow controller is kind of invisible to the nodes on the network, that it just manages the switches. But with this answer that I heard, it appears that the OpenFlow controller is actually susceptible to the denial of service attack by nodes attached to the network.
Yeah, it's a
Which
soup
may
module.
be
Yes.
The controller is a soup module. You need control
it's-
plane
no,
policing.
I know exactly.
Yeah.
So is there any kind of pacing, the policing, or as other vendors call it, the control plane policing or control plane protection feature to protect the controller itself from the attack from malicious users?
Well, yes, it's a very good question, and it is well known in
Okay.
the thing. Completely accepted. What we have done so far right now is just build certain queues on the switch to talk to the controller, so that they are
So the switches are
deprioritize.
trying to pace the control, not to overwhelm the controller.
On some of the traffic, like for example, LLDP is very high priority, so we give that more because if we do not have that, then we lose the whole topology, we lose that. So that way we have done that, but it is not answering the question to the full mark, that we have a way to control that.
No,
or shape it.
but you are aware of the problem.
We are
and
completely,
it is probably going to be down the road, which is
absolutely,
perfectly fine
absolutely,
answer. I mean,
absolutely.
okay,
Our
fair
traffic and its impact on the controller is
Okay.
probably, the.
Oh, I understand
the
the
only
LTP, you're
learned.
using it for the network discovery. That's okay, and it's rather difficult to kind of attack that, but
That's also a problem, because if you have a bare metal server, that can easily flood
oh, absolutely.
with LLDP.
Yeah.
If it's virtualized, it can't because
agree.
ESX is
Yeah.
Sort of
now it even supports LLDP, but you can't flood it through the VM.
Yeah. But it would be a little bit difficult to do it. But if you have a bare metal, you can do
Yeah.
anything. And if you have a malicious user
That's
Yes.
right.
in your network, it can actually bring down your control-based network. I think this is something that.
So
Well,
might want to
you have the
look at-
limitation of the amount of capacity between the CPU of the switch and the controller. And right now, the capacity of the controller is much higher than
Yeah, but
our,
the- but
our
the thing
recommended
is-
scale.
But the thing is here, this has nothing to do with the CPU on the switch. This has to do with the CPU of the server connected to the switch.
Right. No, but
Because
that,
if the switch, if the server that has 10 gig interface starts flooding ARP requests, the switch that server is connected to is not even going to see these, because it's going to be switched in hardware and sent over to the controller, right?
No,
And
it
that
goes
doesn't
to
have good
CPU,
pack
the switch.
capacity.
It does?
Of course.
Wait,
It's control plane.
do what now?
Yeah.
No, it isn't.
Yeah,
ARP?
yeah, yeah. ARP is going
ARP
through
to
the
virtual
CPU.
gateway is control plane.
Yeah, but which control,
Control
plane?
plane
on the
on
switch
the controller,
or on
not
the
on the
controller?
switch.
No, also on the
control
switch.
plane
Get
in this
that
model
into
is the
a
controller.
TLS session.
All right, I think we need to do
Oh,
some
okay.
whiteboarding here.
Yeah, I think we need to get some.
Let's do that over lunch. Let's keep going.
Yeah,
Okay.
you're right.
Fair enough,
So,
fair
so,
enough.
so
Fair
you
enough.
you can do more than 1 gig.
Okay, so
But then
basically,
still, that's-
so basically what I would do if I was the malicious user, what I would affect with my attack on the controller, I would crash the switch that I'm connected to.
That is right. So that's why
Fair
we have the
enough.
queuing.
Fair enough.
We have multiple class
No,
queue
fair
that
enough. Works for me. As long as the controller is protected,
Yes.
I'm good. I mean, it's not perfect, but
Yeah, yeah, yeah.
okay. Fair enough. Thanks.
You're
Where are we?
All right, so now we have two BTNs for two pairs of servers, and it's slow. Slow again. And look at that, the physical view. Now 4 flows. One is between machine 1 and 3, and the other is between machine 2 and 4, like that. And look at that. Now all traffic is going through BFS3, left, top, 1, so it's not distributed. But as Samar said, we have functionality to distribute the traffic as ECMP. So let me try that. One script again, different script to configure the mouth pass number. Right, okay, running. And traffic is going on, and now the traffic is distributed between two switches. So because I configured the match pass as 2. That is the ECMP.
So that script you just ran configured what?
Actually, the meaning part of the script is just configuring the mouth pass number 1, 2,
You
2.
just incremented the
Yes,
multipath.
right,
Okay.
Okay, this is the ECMP part, and next is what's next? Oh, network monitor. All right, network monitor. This was also explained for Samrat. Our controller has a functionality to monitor some server health, and if the server is dead, the controller can switch the traffic to other path. So let me do that. And I'm using different VM. So, and the VTN I'm defining has a L3 functionality. The two VTN already existing are only L2, just bridging. But the VTN I'm defining has L3 functionality with virtual router. So in case, make sure the IP address, this machine is belonging to 101 subnet. So pin to 102 subnet machine, for example, 133. Yeah. Oh, it's okay. Yes, it doesn't work now because there are two reasons. One is there is no VTN between the machines, and the second is there is no router between them. So let me run the script again. Root tech F, no tech network monitor. Okay. All right. So pin starts working beyond the network because now we have a virtual router on the VTN. It's long. Okay. Make sure the traffic. Oh, so many. Which one? Now I'm pinging from L3-1 here to L3-3, so 2 here. So this is the last flow. Which is the first flow? Which is, yes, this is. Now the pin is going to the file 1 and no, it's complicated.
First one.
First one? Here? Okay. To server L3-3. And return path is exactly the same. Where? Yes. To file 1 and which one? No. 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 Which one? Oh, here. Going back. And probably you might notice, firewall 2 is also using, it seems to be used, but look at that. This is only from firewall 2. So, or here, only firewall 2. And there is no input flow to firewall 2. So now firewall 2 is not used. And probably that is refresh and remove. I'm not sure. Oh, there is. Okay, anyway. All right, so now the ping is going through the firewall 1. So let me kill the firewall 1. This is firewall 1, and monitored interface is interface 3, if my memory serves. So I have down ETH 3. And what's happening? Refresh. What's happening? This is outflow, so input flow is, this is not, sorry. This is no matter, input flow, yes, now the input flow is going to firewall 2. That means the path is switched to firewall 2 according to the health of the firewall. All right?
So for that to work, you created the VTN and a layer 3 instance, right?
Yes, this is layer 3.
Where is the layer 3 created?
Layer 3, sorry.
Where's that created? Where's the router?
Oh, where's the router? Yeah, good question. The answer is everywhere and nowhere.
That's exactly right. That's exactly right. Fantastic answer.
And I was never here.
Actually, the functionality of the router is done by the OpenFlow. Rewriting the MAC address. That's all? Yes, rewriting the MAC address.
So it would be done at the local OpenFlow switch then.
Yep.
So the rewriting would be done at the local OpenFlow switch.
So if you look at a routing process in the right way, all you're actually doing is stripping the MAC header and rewriting it and sending it on, because you're receiving it, stripping the layer 2 out, sending it out on a new one.
Right. So we just
OpenFlow,
define.
you create a rule which
So
lunges.
We create a router,
Which is not really a router.
which is not really a router. That's why, yeah.
Well, a router is ultimately a router does two things. One is it determines it routes on the destination address.
Right.
Selects a path according to the destination address, and then rewrites the MAC address as it forwards.
Right. So
That's all the router does.
we would define a router and give it a fake MAC address.
we
Yeah.
would,
Yes,
yes,
yes.
Yeah.
that's
So
right.
we would give it a
We
fake
would
Mac.
create a
only-
flow rule
Right. with
that
flow.
would match
So
the
according-
criteria.
So according to the node, I'm the node on the Linux box with the default gateway, and I would arc for it, and I would get this fake MAC address.
Correct.
And
Just
it'd
like,
be
just
another
like an SVI MAC address.
right, right. So yeah, fake MAC address.
Arbitrary.
Right,
Yeah.
arbitrary MAC address.
It doesn't have to be fake, for that matter.
Well, I mean,
It cannot be fake. So
Right,
it has to respond to
a
it.
real
Yeah.
MAC address for a fake router.
Yeah.
Whatever.
It's a virtual
You get a
MAC
MAC
address for a
address.
virtual
Right,
network.
and then but so the rewrites the rewriting of the MAC address and the routing would be done at the local OpenFlow switch,
Which has a
First
flow
one.
entry, which
And
does the
then-
rewrite.
and it would have its would then flow through the okay.
Does OpenFlow see that as one flow, at the before and after the rewrite?
One, yes.
And I have a follow-up question. There are certain rules that IP routers have to abide by when processing IP headers, like for example, lowering the TTL and stuff like that. Do you do that, given that it's a single flow? I mean, does this process happen, or do you hide the infrastructure in a similar way that MPLS would hide it? I see you smiling, so you knew the question was coming up.
Yeah, the TTLs are not changed, right?
That is not really good.
Well,
That's not
I
good
believe
at
so.
all.
I believe
Well,
so.
where
You would have
TTLs
to-
are needed when you are
Yeah.
going like abroad, you know, but it's just like
Okay, so inside
Fabric, yeah.
inside the OpenFlow.
think it is like a
managed-
single hop router.
That's
I
right.
mean, why do you?
It changes
Yeah.
the TTL, yeah.
Yeah.
But I understand why it's not
Yeah,
necessary.
I get your point.
I understand why it's not necessary inside the confines of OpenFlow, but I suppose you do it when you send it outside of the
No, they don't.
cloud.
Well,
If you have
we
two
would.
OpenFlow
So they have
clouds,
to.
you could
That do you know?
The
Do you
next
know?
hop router would do
Do you
that.
know?
Oh, the next
The
one.
next
Yeah,
Yeah.
it's like considered as like a yeah.
Marco,
The
what if
only
the next
problem
hop
you,
is another
well, there are two
OpenFlow?
problems. One is loop.
Well, your
detection.
controller would see that as an
So
external.
if you
Yeah,
would
exactly.
ever
But they would go
get
forever.
into some weird situation
They
where
don't
someone
decrement.
would insert a
Well, if
bridge
you
in
pass it
there,
down,
you
you
would
would
know
put
that.
the TTL decrement by one.
You could get a forwarding
True,
loop.
true. But remember, we are not
Well, they're not
participating
inside the
in the
cloud
routing
now.
protocols
That's
at
one
this
by
point.
one
of time.
conversation at a time.
But when we do
someone-
that,
if
when
someone would be stupid enough to
yes,
attach a bridge,
You're
and
not
misconfigure
participating in
that,
routing protocol. Hold on, how do you then speak to the outside world?
static routes.
Static routes.
Today.
Today, no,
Today.
I
So-
understand.
so-
And in
understand.
October,
no, it's nothing
In
like
October, you'll
theoretical
have
or possible. You
BGP
can
with
implement that in the controller. You can implement all
Yeah,
the
sure.
BGP and everything.
So
I think
what's
that's
happening is the vendors, the OpenFlow vendors, are choosing a marketplace to attack, right?
No,
So, for example,
I
Ericsson
understand.
is
I understand.
So Ericsson, for example,
Look,
is
I think
producing
we-
OpenFlow
We
controllers.
need diagrams. We need the whiteboard
Yeah,
because
we'll do that over lunch. But for example, Ericsson is attacking MPLS-TE in the controller, and they will provide BGP MPLS-TE for service provider edge integration. NEC is attacking a different marketplace, so their OpenFlow application attacks a different functionality pool. And Big Switch does it
no,
differently again.
I understand that, but sometimes you want to break the traffic outside of your data center. I mean, it's not all the traffic that stays
so
inside
right
the data
now
center.
you're right. So right now the situation is that you do the fabric when you go out. You take a legacy WAN router,
Okay.
Yeah.
take it to the legacy WAN router and the WAN router.
Fair enough.
Because if
Plug
you
it
look
into
at
your
it, you
Nexus
know
7000
Yeah,
and
fair
the
enough,
WAN
fair enough,
routers
fair
are
enough,
working
fair enough,
fine.
fair enough.
I mean, there is no need to replace
Fair
them.
enough, and that answers my concern that I had about
Yeah.
not lowering the TTL.
Yeah, and
Because
the-
when everything happens in this the small happy cloud, then it's all okay. When it goes out, it's not your responsibility, and technically speaking, you don't care because you are solving a different problem.
That's right.
Perfectly fine.
Exactly.
Yeah, and the problem is bound, right?
Exactly.
Bound inside
Right.
the confines of
Inside
the.
the confines of the
Exactly,
fabric.
exactly.
So you're
Fair
not
enough.
solving all the problems of the universe or every problem that the networking industry has not yet thought of. You're bounding the problem inside your 20, 30, 50 switches in the tops of racks for where you need virtual networking. that
I'm
needs
utterly disappointed by the fact that they're not solving every single.
But he said that he thought the TTL was decremented, and that is that's a function of the forwarding hardware, right? That's something you can ask forwarding hardware to do. So is there something? Can you verify if it's doing that?
Sure. Do you know that? Anything on that?
No, I think the answer was no.
Well,
OpenFlow
he
has
said he thought that it did.
Okay.
It didn't.
OpenFlow has
Before
TTL
it didn't.
decrement action, so it should be possible
Yeah.
to do that.
It would be a fun. So the interesting thing here to note is that in that we talk about a routing action,
So
and all we're doing is rewriting the MAC address in a rule.
So something
also
might
possible-
have been changed in the new version, but we are not confirmed yet. But we can.
Fair
let you
enough.
Yeah.
Fair enough.
So hypothetically, if it's not done today, it could be done in the future. Because once
Sure.
you start rewriting a frame, whether you rewrite the IP header destination, source, MAC address header, source, insert an MPLS tag, strip an MPLS tag because you're externalizing the flow into a legacy network like MPLS clouds.
That's an open
Then-
flow action
Once you're actually munging the frame, you can actually munge anything from the 12 side.
because it's done on the
So-
packet level
You get full policy-based routing
by open flow
for
action.
every flow.
Yep.
And that's the key thing from OpenFlow that excites me, is it's not just about emulating a router
That's what I think.
using flow rules, it's about being able to route on source and destination for every packet.
Well, they would, right now, they wouldn't scale for that. Right now, their product does mass-based flows. It only takes 750 12-tuple flows,
Yep.
right?
But that's today, and then over time, over a 2, 5, 10-year cycle, as our data centers today are still only hosting, your typical data center is only hosting 50 blade chassis, and 50 blade chassis gives you, a lot of physical servers with a 20-to-1 ratio. So if you say 50 blades with, say, even worst case, 8 blades per chassis, that gives you 400 blades. And if you're running 20-to-1, that gives you 9 on 8,000. I get that right? 400 times. Anyway, 8,000 virtual instances. That's an awful lot of servers in 50 chassis. 50 chassis at 4 per rack is 12 racks. That's 25 switches. So 25, an OpenFlow network with 50 blade servers could be serviced by 25 switches and deliver you 8,000 virtual instances at a 20-to-1 ratio. And you'd have full control right the way down to the flow level.
In the future. But
In the future, it'd be
yeah,
bigger.
but I mean, what would? Well, I mean, let's just keep going.
Yeah.
We'll have this because I a little bit disagree with that. But
So real quick before you go any further, I have a question about this because we've been talking fabrics throughout the week. We talked about it the other day. One of the things that we've talked about with fabrics over the last couple of years is that the wiring structure in the physical plant looks very different for every fabric. We keep talking about commodity-based hardware, multiple vendor hardware with OpenFlow controllers, then being the intelligence behind it. What does the actual physical architecture look like? Because in my mind, when I start thinking about OpenFlow, I start thinking about highly meshed environments that are very, very dense, or at least a couple lanes being very dense lanes, like big bonded links, that kind of thing. What's kind of the reference architecture you guys are looking at for this, for what the architecture actually looks like, to be able to say traffic flow goes this way and this way and this way and this way and this way? I mean, it's interesting to me because as we build data centers out, if we're going to highly mesh this stuff, if there's going to be cost return in having commodity-based, multi-vendor switches, are we going to burn it all up in infrastructure again?
So you're asking about the topology of connecting
What the
switch?
physical topology looks like. So when you build a data center to do
Yeah.
OpenFlow and to do all this massive SDN stuff, what does it look like? Because we can't ignore that.
Well, these two things are in general decoupled because the topology is more about the traffic pattern you have, what level of oversubscription you want to keep, like you can have a class or hypercube or mesh or tree topology. The good part which you're saying is that you give the topology to them, to the controller, and it will try to maximize the topology efficiency in terms of the traffic forwarding. But if you ask like how, what, we have seen different, like most cases it is about the reliability. You have at least multiple paths between the racks, and then you have also multiple paths for backups. But exactly
So if you guys are going to dump this into a greenfield high availability data center right now, you guys don't have a reference model for this.
Depends on the application.
Right now, the reference models are also shifting, from north, south, east, west. But like I said, it's all different.
So
All
what are,
different, like-
maybe that's something you'll cover. What are they initially in terms of?
Yeah, so we've had customers that are purely north-south, and customers that 80% east-west design. So those are much different topologies, right?
Like, yeah, exactly. Like tree routed ones, very much like simple.
So,
Josh, this is like you would build a routed network.
no, it's not.
Well, from
The-
the,
the
from
entire
the
mo-
topology perspective, it is.
It's
You're
absolutely
no
not.
longer.
The entire model for the last 3 years in data centers, and we're talking data centers, we're not talking enterprise, we're not talking service
Okay.
providers right now. This is data center. Let's
Yeah.
just be honest where this is going to be for the next 5 years. So when you start talking about data center, people are building these data centers out for wire once. They're wanting architectures and infrastructures that you wire these things once, you wire a pod, and you never wire the frickin' thing again. That's where all the data values come. That's how lots and lots of data centers have been built over the last couple of years. So you've got a certain amount of fiber and a certain amount of copper pulled. You've got them wired left, right, or so east, west, north, south, back to core spaces in certain directions. I'm curious what the reference architecture. There's got to be a reference architecture.
No, it depends on your traffic flow. I mean, you can build the class fabric, well, the class.
No, we're
Yeah,
effective.
fabric.
We're effectively, in my mind, if I was going to build this today, I would build just 8 lanes of 10 gig in every single direction if I had the path, because I don't know what's coming in the future.
No.
And then I'm going to use this reference. I'm going to use the software-defined networking to then optimize that design.
Sure.
To
But I
go
wouldn't do
whichever
that.
direction.
I would go in and connect up one of everything and use the software-defined networking to tell me where I should connect the second, third, and fourth of everything. So you're in the old mindset where you would plug everything in.
I'm not arguing that point at all.
Right? I would go back and say one of everything everywhere. Now look at my flows, see where my bandwidth is, and then start plumbing, and then start my meshing.
That's actually a brilliant comment. You can
Right.
use the OpenFlow controller to actually establish
And
the
maybe that's what
baseline
I'm getting at.
in your
Well-
data center, which I think
So there are no
is a
reference
value that I personally missed.
I like
Start
that.
there with
Yeah.
the solar wind comparison.
Yeah.
I mean,
So-
we have to start with some place
That's right.
to explain to people like me who are too dumb to get it,
Yeah.
to where to take this.
Yeah, if it's not a reference architecture, then it has to be, you know, basically best practices for certain applications.
And I love
I'll just
that.
make stuff up.
If that makes
I mean, I just look at the problem and it seems obvious to me. The problem that we have today is we either over-engineer or we don't have the flexibility to put bandwidth where we need to go. The point about OpenFlow is it leaves all that open. There are no arbitrary limits. Spanning tree says you have to do this. Lag means you have a design that looks like
Right.
this.
Right.
MLAG means this is an enforced invariant point in your design process.
Right.
OpenFlow takes all that away and lets you do as much stupidity as you like.
And
Right?
that's why it said that it's topology free. You
Yeah.
design your topology, you
Yeah.
add, scale out your
No, but
topology.
what Josh was really asking is he wants to wire the things now.
Once.
Yeah, it is, I mean, you're asking, how do I wire it if I don't know?
Yeah.
Yeah,
How do you start?
yeah.
I think you should take Greg's idea and it should become your base reference
Yeah.
architecture.
Well,
You
I
can't
think one of the
plumb it
others.
by itself. You can't just sit there and plumb an OpenFlow infrastructure, but it's going to be part of these servers, these applications are all going to work together, and the flows are going to look like this. Therefore, I need to plumb it in this way.
So
Build a
I-
pod, then we go forward.
I think
they walk in like
I
that.
think that's
I
a
think
perfect
our-
idea.
I think our
One person
brains
at
are
a
doing
time.
network
Tough
discovery
questions.
right now of how OpenFlow works. So the concept of OpenFlow and versus the concept of NEC's version of
Yes, I did.
OpenFlow,
'Cause
which right now isn't. It has some limitations, which is fine because it's a new product and this is a new frontier. But I think a lot of us are trying to plumb how OpenFlow even works.
Well, this is the same problem that Brocade talked about 2 days ago. They're like, well, VCS, we had a commercial with children that just slung cables and it passed packets. Well, sure, you can do that with this as well.
Yep.
That doesn't mean you're going to design it that way. If you look, I know QFabric is not OpenFlow, but if you take a step back, it's network system,
It's
single
cross
system image,
fabric.
right? And what they decided to do with QFabric is they made a full mesh between all of those disembodied line cards. That
It's
was
not
their
a full, it's not a full mesh, it's a class fabric.
sure,
Sorry,
but logically they
it's a
can.
class fabric.
Okay, fine.
I would just like to make a comment on one thing that I heard.
Derek, sorry. This is an important point because it's the same thing like that's why I said to George before. It's like you would build your routed network. Okay. Now we are no longer limited by spanning tree. We can connect anything to anything. Everything will work. Equal cost multipath will work. But just randomly connecting things together is not the best way to design your network. It has never been.
Fully
Full
agree.
mesh is not the best way to design your network. It has never been. There are reference architectures that have worked in the past for large layer 3 networks. And you can start using them today because you're not limited by the spamming tree.
No, but there was one
And
comment.
Cross Fabric is one of those. If you need any-to-any traffic.
Well, one of the things that I heard was that
Is
this
it
is NEC's version of OpenFlow. The way I understand it, and I'm sure that Greg would correct me if I'm wrong, is that there is really no NEC's version of OpenFlow. It's their implementation of the standard. But if the
It's not an
OpenFlow,
implementation of the standard.
It's-
It's the app.
that's
It's the
right.
controller.
That's the right.
Exactly.
Right.
Which means that all the functionality that we are talking about here now and that we are discussing, it is just up to their customer and the business model that they want to go into, whether they're going to implement it or not. We have to make that distinction. And also what Ivan is saying here is we have to make a clear distinction between what is possible and what should be done. And the fact that you can do something doesn't mean that you should do it.
Right.
We all know that.
Yep.
You know, so the questions I have basically about OpenFlow are, what is possible with OpenFlow in terms of just what is possible in general? Still don't have that picture yet in my head, and you know, we're asking these questions. I think all of us are trying to build that model, or most of us are trying to build that model. 2, how does it interact with the nodes and the other networks? 3, what is possible with OpenFlow, with NEC's OpenFlow app? So I think we're kind of murky on all of that right now, and that's just because OpenFlow is very new to most of us.
I think it's not just OpenFlow. OpenFlow is a small piece of this, and that's what Greg's getting at,
Yeah.
is that you need to look at the applications, and you need to look at what you're doing on the control plane.
Yes.
And OpenFlow is a lower level mechanism.
Yes.
Yeah.
For realizing.
And that's a really good one, because if you consider what we've been doing today, we haven't been discussing OpenFlow at all.
No, not really.
That's irrelevant.
It is irrelevant.
We've been discussing OpenFlow only when we were discussing the flow download rate.
Yes.
That was the only OpenFlow discussion of the whole 2 hours. Everything else we were discussing was your controller.
Right.
Okay, so the real question though, it's not even about OpenFlow, it's how do you design for single system image platforms? Because and however you answer that is valid for any single system image platform, whether it's based on OpenFlow or not. And that's a new problem that network engineers have not had to think about.
No,
All right.
network engineers have solved that 30 years ago with frame relay and ATM networks. Sorry.
Circuit-oriented network.
In 5%.
Okay, we have
But this is
to.
the same concept.
Okay, we have
You
to.
might not like the answer, but there is some
So
knowledge
you're
there.
saying that there's a central controller for frame relay, there wasn't local intelligence on each node?
Yes.
Of course not.
Okay, so we have to wrap it up. Thanks very much, Don.
Thank you, everyone.
Thank you so
Thank
much.
you very much.
Thank you.
Thank you for giving us a demo. It was as good as always.